Good afternoon and welcome to our 20th annual exhibit of hydrogen and fuel cell technologies. We've added batteries to the mix this year, so there's something new. We'll be talking about interesting issues all day long, so please sit down, have a drink. The drinks are on the house. The hostesses will be serving them continually during the presentation. We all know that the price of energy is going up, up, up. And we have people worried about this, and we have solutions to bring that price down, down, down. Someone who's working on this issue is going to be up on the stage just this moment. I'm going to be talking to Dr. Manfred Stefener. He's CEO at Elcore, and he's going to tell us about the new technology he's offering this year. Please welcome with me Dr. Manfred Stefener. So, good afternoon. Early afternoon. So perhaps we could start with a brief introduction about the company, Elcore. Could you tell us a bit about what you do?
Yes, of course. So I started the company Elcore about 7 years ago. So it's a Munich-based company. So we're about like 80 employees at the moment. And what we are doing is we're doing a stationary cogeneration unit, so we produce electricity and heat at the same time. The product that we have currently on the market is called Elcore 2400, and this product is targeting single homes.
So single home applications, of course, every time we have a home-based application, everyone wants to know, have you got them up and running? How are they being accepted? How's the interplay between the consumer and the technology? Is it a good fit? Are there places where there are things rubbing? So how's it going?
Okay, so there's definitely a lot of stories to tell, but maybe to start with a little bit the number base. So we started to install units last year, and we have worked through different programs. So one of the programs here sponsored by the NIP and the NOW. So there was a program where we installed 50 units, and we are working at the moment through like the Ennefield program, so the European program for stationary cogeneration units. So there we have like in total 135. So and we are a pretty active party in this. So last year we have managed to be one of the first installed units under this program. So and there's another program waiting for us. That's another NOW program. So with 400 units. So pretty active times at the moment, and very exciting time.
Okay, we have a mixture in the audience, people who are interested in the technology, and then I bet about half of these people here are geeks and nerds. They want to know the hard data. Let's get into the details. What is the Elcore 2400? What type of combined heat production unit is it? What is it based on? And what does it produce?
Okay, so first of all, so the technology base is a so-called high-temperature PEM fuel cell that we're using, so which is operated at 160 degrees Celsius, which has like a lot of advantages in the technology, and so it's a technology which is very durable and which has its benefits, especially in stationary cogeneration applications. One important aspect that we found out in the last year is that here in Germany, so we have the topic of different gas qualities, high caloric gas and low caloric gas, H and L gas. We clearly see that based on our technology, this is basically no problem to achieve. So we can cope with both gases. This is important because not all units can do that, and L-gas, which is the most difficult one, can contain up to 10 to 20% of nitrogen coming from the North Sea. Is technologically a difficult target, but like the technology easily manages to do it. This is basically one of the important examples that we found out where technology base has like an advantage.
You mentioned the two types of gases. Some people are smiling. Let's clarify the issue here. Where does the low caloric gas come from, and where does the high caloric gas come from, and which gas might be turned off if we say the wrong things?
Okay, so there. So to make like a long story, maybe or try to make it short, is so like we have high caloric gas basically coming from Russia with about 98% methane content, and we have low caloric gas basically coming from the North Sea. So with like a high amount of nitrogen, and nitrogen can form like substances that impact negatively the fuel cell. So in terms of turning off, yeah, so it depends on what you expect, yeah. So like Russians are also always tending, at this time maybe turn off the gas. But I think, of course, the North Sea gas is the most limited gas that we have. So the amount of North Sea gas will definitely go down over the years.
So the supplies may change, and this technology does both things. Okay, you've got these things up and running. There's always issues when you approach commercialization of how acceptable the technology is to the consumer. What does it feel like? We actually have some photos, by the way, that are running up here. Yeah, you can see the unit. Perhaps you could describe the two slides that are being shown. Okay, so
maybe so if you can see the next slide, so I can definitely talk about the installations. So in principle, so we have clearly seen that there's a high acceptance of the customer of our concept that we are offered to the market. So the concept is that we have a cogeneration unit that covers the base load of heat and electricity in a house. Yeah, the base load of the heat is important to get runtime hours on the system. Like every power plant, yeah, and the fuel cell is a small power plant, is more economic if it runs more runtime hours per year. So and here, as the unit also creates heat, we need to assure that the unit runs over the full year. So this can be done if we cover the warm water demand that a house has and not the heating demand. So and we clearly see that customers accept especially this concept. On the electricity side, we have like a similar situation. We cover the base load of the electricity, which is between 50 and 70% of the total demand that a household has. And our Elcore 2400 covers exactly this demand, and we clearly avoid to feed electricity into the grid, because this would hurt the economics of the unit. So we have designed the unit that we can use the electricity completely in a house. So and this concept leads to the situation that the customer can save about 800 euro every year on the electricity side, and additional 400 to 500 euros on the heat side. So in total 1200 to 1300 euros savings per year. And that is like a very attractive concept that we offer to the market.
Manfred, I almost have to reformulate that, because I find this a point that is easily missed. Many of the units that are being installed right now, the stationary units, they basically cover the entire energy budget of a house. And every time there is an excess potential of energy, they would like to stick it back into the grid, but they'd be selling it at horrendously cheap prices. You would have to have an intelligent grid system to deal with an entire structure here. What I find so intriguing about your system, and such a logically clear thing to do, is to say, we'll install it in your place, you keep your conventional heating system. I think this is really important. You keep your general conventional heating system, you install this system though, and it supplies at a savings let's say the mean demand, the average demand, the 50 or 60% of the electrical energy, and the standard water demand, which doesn't change whether it's winter or summer. Sorry, were you...
I just ordered the next slide.
Oh, yeah,
it's
okay.
Here.
Yeah, you can see the unit right here. So go back to your details here. Here we have the unit installed in the house.
Yeah, exactly. Coming to your question, you're absolutely right. Yeah, so we can install the unit in existing heating systems. So that means it's not only applicable to new homes or like to a total exchange of the heating system. And the interesting story is that basically our installers started to advertise the system with exactly that argument. Yeah, so that they said, so you can keep your old system, and maybe your boiler that you that you have will run like 10 years longer, because now when the fuel cell is installed, this boiler runs only like 3 months a year for the heating demand, and the other 9 months in summertime it stands still, and that increases also the lifetime of the boiler. So for the end customer, it's definitely beneficial to retrofit our unit in existing systems. Yeah. So, and we have seen in the meanwhile a lot of retrofits, not only to gas systems, but we have, for example, also already one installation where like a customer combined this with a wood pellet heating system. Yeah. So very interesting combinations possible.
And what I find interesting, again, this is the logistic choice. You structure the system so that it is operating at around its optimal capacity as often as possible, so the returns on your investment are going to be predictable and continuous. You seem to have calculated the financial side into the structure.
Exactly. So and this is an important point. And the interesting part. So there is like, for example, the demand that you have in typical homes in Germany, but also all over Europe. So it's applicable to about, like, I would say at the moment 7 million homes in Germany, 15 million homes in UK. Like in total Europe, about 50 million homes. So where our system would be able to be retrofitted, and it's pretty, so there are basically data to calculate like the base load demand for heat and electricity in these homes. And the interesting part is that it's always, like in all these homes, it's basically the same level. It's 300 watt electricity base load and about 600 watt thermal for warm water. And this is like over like this amount of houses, it's pretty similar. Yeah, so this unit can be used everywhere basically, and as you see here in the pictures, it is very easy to install. It looks like basically a normal gas boiler, and all the interfaces that we have with the unit are identical with a normal gas boiler.
So you got these things up and running, and of course, a number of issues there when you're operating systems. We have the conventional lifespan of the traditional heating systems. We know about that. They do deteriorate over time, but they have a relatively long lifespan. What are we talking about when we talk about the lifespan of this unit, and at what point does it become a financial interest to save on CO2 emissions and save money at the same time?
So in terms of lifespan, so we have designed the units for 15 years lifetime, so which is basically equally to what like a typical gas condensing boiler has. So as I mentioned, so we can save about 1,200 to 1,300 euro per year, so which results into like about an 8-year payback period. So after 8 years, the unit has paid back, and the rest of the life, so the end customer makes money with the unit.
And of course, it's the electrical energy costs right now that are rising so dramatically. So does this sort of feed into the design that you've given? Basically, you cover the base energy, electrical energy demand. Was this a calculated decision also to say, okay, the electricity is the expensive thing, the conventional boiler is almost criminally inexpensive. It's old technology, but it really is cheap right now. But the electrical energy costs are rising dramatically. So have you specifically targeted the electrical budget in designing this device?
Yeah, of course. If you talk about a fuel cell, of course, like the electrical part is, or the electrical design is definitely a priority, and that's definitely the higher savings that you can make. And here, that was like a very clear analysis to choose that point of 300 watt base load and to avoid feeding into the grid, so that the end customer can self-consume all the electrical power that the unit gives. But it's a cogeneration unit, and we don't have to forget like the heat part. And operating like a unit 8,000 hours per year in the optimal design point and at optimal efficiency. Yeah, so and the efficiency of our unit is close to 100%. Brings also like significant savings on the efficiency side to the end customer, and as a result, the CO2 emissions of the household are reduced by 50% almost. Yeah. Compared like with the same energy use like with conventional technologies.
What are your next steps right now? Of course, there's all sorts of potential innovations, changes. There's manufacturing ideas. You know, how is the step towards mass production of these units? How do you envision that? Are you moving towards a larger quantity of units being produced? Are we moving into a direct marketing stage? Where are you going with this?
Okay, so that question has also like different aspects, but so on the manufacturing side, so we are definitely now in the phase where like the scale up of the manufacturing, increasing the capacity, is very important, and here, of course, we clearly see that we in future want to partner up more with suppliers to use like mass manufacturing technologies to combine components and to increase volume. And this is definitely an important part on the sales side. We definitely see that we want to offer like also like products around the Elcore 2400. One example is like an installation set that we are offering in the meanwhile. And we have made the experience that the installer can much easier install such a unit if he has like a pre-configured tubing and a hot water tank, for example, and other aspects. And here, like the cost of installation goes dramatically down.
Okay. I should mention that we do have time for questions from the audience. If there are any questions, just raise your hand and I'll bring a microphone over to you. Barring that, let's continue with a few of the local issues here. One of them, of course, is that in this entire industry, we're wondering whether we're getting fair coverage in the media and whether the political support, I mean, we do have these CO2 emission reduction rules, ideas, we all have to do something about that. Is the fuel cell industry, are you getting enough support, do you think, from the government, from those who create standards, make the rules for installing this stuff? Do you feel left alone or do you feel aided in the current situation?
So also this question has a lot of aspects. So first of all, we are here on the joint booth with all fuel cell companies, and so the NEP program, NOW program, so that has helped the fuel cell industry a lot. Yeah, that was like a total program of 1.4 billion. So and still is. Yeah. So and this is like was like a significant help to the fuel cell industry. But on the other hand, so we are now at the stage, and I think this is important to mention. So fuel cell technology has always been waited for, and now we clearly see systems and products that are ready for the market, and here we clearly need like further support from the government. Yeah, of course, we would definitely see that find it very positive if like the NEP program 2.0 will be introduced. I think that's a very important program to be continued. So in terms of stationary units, we clearly see that there's a lot of regulations around it. So we have to fill out forms that are basically meant for megawatt plants, and so we have here like power plants in the region of like between 300 watt and 1.5 kilowatt. And if you, for example, switch on your vacuum cleaner or your electrical stove at home, so that has more impact to the grid than our units. And we still need like significant bureaucracy to to install these units, and I think that has to be reduced. So, and here we need support then from the renewable energy law. So we have just seen that the self-production and consumption of energy, so there was put like a burden on it, and that hurts basically some of the units in the field. And we clearly believe that this needs a careful look at that we can reduce like these hurdles, and then of course we have in the coalition contract that for CHP applications we want to have in Germany 25% coverage in the year 2020. So what we would like to see is definitely like the respective measures to make that a reality, and we don't see that at the moment. So, and these are would be additional points that we would wish to be supported from the politics.
Well, we've just heard a perfect definition of what they call Beamtenmentalität, and that is, it's easier to make the people follow the rules even if they don't make sense than to try and change them. In the hope that things do change, it's been a thrill talking to you. I've been talking to Dr. Manfred Stefener, CEO at Elcore. This is very important technology. You have to visit his booth. It's E51 over in this direction. For me, it was a shock during the preparation. I discovered, oh, this is not a replacement unit. You are offering a unique take on what you can do with fuel cell technology. We welcome all here. It's been a pleasure talking to you, and I wish you all the success.
Thank you very much.
Thank you.